Hello guys, I hope all of you are fine at home. In the last class, we have covered deadlock avoidance method, right? Uh, yes, deadlock avoidance method. And we understood the assumptions of deadlock avoidance method and what is state, resource allocation state, which is simply a function of number of available, number of allocated, and number of max demand of a process, right? And requirement of deadlock avoidance, and if we somehow able to generate a safe sequence of processes after getting the advanced information of resource requirement of every process in the system, then we can say that this system is in safe state. That directly means there is no deadlock in this, right? After that, we have discussed Banker's algorithm, which we use for multiple instances of resource type if we are having multiple resources instances of resource type, right? And in the last lecture, what simply we understood that Banker's algorithm uses two algorithm underneath it. One is safety algorithm and second one is resource request algorithm, right? And safety algorithm is generally used to check the safe sequence in the system, and request algorithm, second one, is being used for checking that if the new resource request has come to the system, whether it will be allocated to the requesting process or not, right? So this is the combination of two algorithms. After that we have covered common data structure this algorithm uses, where we understood, we simply got the syntaxes we used for our algorithm, which is n shows the number of processes in the system, and m will be the number of resource types in the system. And the first data structure will be available, second max, third is allocation and need. And now, after discussing these all data structure, let us understand how we can view them in system, right? Or in the given question, right? So by using this example we can understand it. Let's say timestamp at timestamp t0 t0 snap sort of our system is like given below, right? So for better understanding purpose, we generally use tabular format, right? This will be allocation, this will be max, this will be available, and this will be need, right? And we have three resource type in the system. Let's ABC. Let us say ABC. ABC. These are the three resource type in the system which are or which can be given to any requesting resource. So in total there are multiple instances of these three types of resource type, right? So we will understand first tabular form, how we will look into the table. Let's say we have three processes P1, P2 and P3, right? So allocation, what allocation is defining here. See, we understood in the last lecture what is allocation. Allocation is a matrix of n by m. What it means, it will be the matrix of processes and matrix of resources, uh, matrix of process multiplied by or by resource. So we have process, three number of processes. So three number of processes will be like this and three number of resource like this. So we will get a matrix of allocation, right? So let us say it is given here something like that: 0 1 0 3 0 2 3 0 2. Let us say maximum matrix, max matrix is for this for P1, this for P2, and 9 0 2 for P3. And currently available instances of in the system are 230. Now suppose you have given this in the question, then what will you understand from this? Let us try to analyze it first, right? So if, let us check for P3 first, P1 first, right? So allocation will be a matrix of n by m. Max will also be a matrix of n by m, which is given in the algorithm. This will be a vector of m. See, we have defined it. See, vector of length m. M is a, and what is m? M is a number of resource type, right? So now let us understand how we will analyze this, right? So this vector of available is simply showing that currently at time stamp t0 system has two instances of A, three instances of B, and zero instances of C resource type in the system. See here, 2 3 0, right? What it means that we after allocation of these many resources, after allocation of these many resources to the different processes, we are having the two instances of A, three instances of B, and zero instances of C currently available with the system, right? Which we can allocate freely, right? Now check how many. Let us first check how to calculate that how many total instances of A, total instances of B, and total instances of C we are having in the system. So for that one, what you will need, you have to check how many total instances of the A in the system. So first two are available, okay, 2 plus which these are available, and these many have been allocated, that means 2 plus 3 plus 3, right? That means we are having total of 8 instances of resource type A in the system, right? These are instances of resource type A, right? In a similar way, we can find that there are three currently available instances of B, and how many has been already allocated? There is one, right? The one is already allocated to the P1. So there is total of four instances available. Total of four instances are available in the system of resource type B. Now come to the C. 0 has been remaining, and total of 2 plus 2 has been allocated. That means C, 4 instances of C has been or are available in the system, right? So this is what, these are the total resources of A type, B type and C type we are having in the system, and out of these only operating system can allocate these resources or these instances to the P1, P2, P3, right? So this is what we understood, that how to calculate total number of, because if you don't know the total number of instances available with you or with the system, how you can be sure about allocation. There will be a chance that you can allocate more than available instances, right? So for ensuring the correctness of your solution, you must understand that you need to check that how many instances are total of any resource type in the system, right? Now come to the point. Now if we are reading for P1, we will say, we will simply say this max matrix, what it is showing, it is simply showing that P1 will need at most 7 instances of A, 5 instances of B and 3 instances of C type for completion of its task, right? That means it is the maximum demand of a process P1. In the same way, 322 is the maximum demand of process P2. What it means? It simply means process P2 will require maximum 3 instances of A, 2 instances of B and 3 instances of C type in its lifetime, or for its execution of its task, right? In the same way, P3 will require these many resources of, or these many instances of A, these many instances of B, these many instances of C in the lifetime of its execution, right? So now you got my point, that these allocation matrix is simply showing that these many instances of different resource type has been already allocated to this particular process. In the same way, these many instances of resource type ABC has been already allocated to P2, right? In the same way, P3. And these are the total availability. See, this is vector, this is not matrix. This is only vector. Why? Because we are having certain number of instances for resource type A, resource type B and resource type C, and these only these instances will be, out of these instances we will allocate some instances to the requesting processes only. That's why it is not a matrix. It will, these are the resources, they will be only vector form, right? It will not create any matrix, because we are not having different uh, instances for different processes. We are having common instances of any resource type for all the processes available in the system. Now in the question, generally you will be getting only these three entries. You will be getting only allocation matrix, max demand of a process and available vector, right? But if examiner wanted to make question easy for you guys, then it will give you need vector also. And if it is given, then very good. If it is not given, then you have to calculate need vector also, right? Then you have to calculate need vector from this one. So how I can find the need of a particular process is simply calculated by maximum demand of that particular process minus total allocated resources to that process, right? So let us calculate it now. Let us assume that we are not having having need matrix directly, we have to calculate it. So it's very easy. Let us calculate. So need, let us first calculate need for P1. So max minus allocation. Maximum demand of P1 for resource A type is 7, and how many is allocated to it? 0. That means the need of this A resource type will be 7, right? Obviously, because it wanted 7 instances, but it has been allocated 0. That means obviously it needs 7, right? That's why we have calculated 7, right? Now for resource type B, it has maximum demand of 5 and has been allocated with 1 instance. That means 5 minus 1, that means 4 will be the need for this resource type for P1, right? In the same way, we can calculate resource type C. 3 is the maximum demand and 0 has been allocated. That means 3 will be 3 will be the need 3 instances of the C resource type will be required by process P1. In the same way, we can calculate for P2, right, and P3, right? So this is what we are simply understanding how to read the given question, right? So it will help you in numerical part, right? That's why I make it first understand it to you, so that you got the point how to read question first, or how to understand the given question first. Then only we can solve it, right? Now let us, before going to the numerical part, we have to first write our algorithm. So come to the first part. First algorithm we are having in the bankers algorithm is safety algorithm. We are talking about avoidance method, right? The safety algorithm. So let us understand step by step algorithm. First one, step 1. In the step 1, we will let work as vector of m, and m is number of resources, right? Similarly, we will start with finish, which will also be a vector of n, where n is number of processes. So we will use two variables, work and finish. Work is for number of resources, and finish is used for number of processes in the system, right? So we will initialize them with work equals to available. So we will initialize work with available. That means resources available with us. So we will initialize work with available vector, right? And finish with false for I equals to 1, 2, 3, dot dot dot, and right. So this is the initialization step. So we have used work variable, which will be initialized with available vector, and we will initialize a boolean array of boolean type finish I, which will be initialized with false for all i's, right? In the step 2, what we'll do, we'll find I such that both, remember both is written here, both, what both are? A finis I equals to false. We will find I such that for which I finis I will be false, as well as need of I is less than equals to work. Right, we will find where finish I will be false and need of ith process is less than our work, and which is equals to our availability. Right, you will understand it very clear when we will solve a numerical on it. Right, if no such I exist, then go to step 4. Right, if no such I exists, then directly go to step 4. That simply directly means that for all I finishes false only, right? But need is greater than work. That's why we are not getting any access grant. Right, now come to step 3, where we will modify our variables. Right, we will update our values of variables. So we will update work by work plus allocation of I. This is I, not semicolon. Right, and finish of I will be set to true, and again go to step number 2. Right, and after that step 4, last step of the algorithm, if finish I equals to true for all I, then system is in a safe state, else system is in unsafe state. Right, so when we run this algorithm on this type of questions, it will simply check that the system is in safe state or not, and if it is safe state, that means it will generate a safe sequence for you guys. Right, we'll understand how it will generate safe sequence by using example. Right, but before that we have to just write that theory or algorithm first. Right, so simply what this algorithm is doing, this algorithm is giving this algorithm gives safe sequence such that P1, P2, P5, P4, P2 in output, right? That means it will simply generate safe sequence. If the system is in safe state, then it will generate a safe sequence for this system. If it is not generating safe sequence, it is unable to generate the safe sequence. That means system is not in safe sequence, right guys? So this is our safety algorithm, which is algorithm 1. Now come to second part. Second algorithm we are having in deadlock avoidance. Let's choose another color. Let us take blue one. Second algorithm we are having in banker's algorithm is resource request algorithm. Resource request algorithm. What it will do, it will simply check whether the new requested resource can be granted to the requesting process or not, right? So how it will work, let us check. Let request of I will signify or is request vector for process pi. And if we are writing something like that, request of I j equals to k, it directly signifies that process pi, see, I process pi wants k instances of resource type R J, right? As we understood this this syntax in the last class, like here and like here. In the same way, if we have written request I j equals to k, that directly means, or that simply signify process pi wants k instances of resource type rj, right? Now let's move ahead. When a request for resource is made by process pi following action are taken, right? If PI will request any resource or requesting for resource, then following actions will be taken, right? And this algorithm works like, in the step 1, what it will do, step 1 in the step 1 what it will do, it will check if request of I is less than equals to need of I, right? If this is the case, then go to then go to step 2, right? Else else if the request number of requests it is doing it is asking for, or number of requests it is making is less than the need of that particular resource, then it can go ahead. Else simply what it directly means, if this is not the case, that means it will it will not be granted, as the requesting process has demanding more resources which has been declared earlier by that particular process, right? Then else part, in the else part, you'll simply raise an exception or error as the process has exceeded its maximum claim, right? If it is requesting more than its need, that means it is exceeding its maximum claim, right? Which it is allowed to do, because if it has declared that it will need the 10 instances of resource type A, that means it can maximum demand 10 instances, right? And if it is demanding more than 10, that means this is not fair, right? So it will not be granted, so it will raise an exception or error to that particular requesting process that you have exceeded the demand, right? You have exceeded the your claim limit, right? So in the step 1 it will simply check this condition, and according to this condition only it will go ahead or stop the working. Now in the step 2, if first step has been cleared successfully, that means this condition has been uh, met successfully, then we will check if request of I is less than available. First we are checking that it is not exceeding its maximum claim. After that we will check that how much the request uh, has been put by that particular process, whether it is they are available or not. If that number of requests or that number of instances are available only, then only we will move ahead, else we have to stop there. That means go to step number 3, right? Else if this is not the case, else simply PI requesting process must wait since the resource are not available, right? Let us if PI is requesting 7 instances and total available instances in the system at that time is only 2, then it has to wait until and unless it is 7 instances of that particular resource type is not being available for that particular process. It has to wait, right? Now let's assume if this is not the case, in the normal case request of I is less than available, then in the third step we will simply allocate those resources to that requesting process. So requested resources are allocated to process PI by modifying states as follows. So how we'll modify the states are simply we will update available equals to available minus request of I. See, if we are allocating resource to process PI, what it means, we are simply decreasing the available part, right? So we will decrease available by number of resources put by that particular process. That's why available will be updated as available equals to available minus request of I, right? And along with available, obviously allocation will have to be updated, right? So allocation of I will be updated with allocation of I previous allocation plus granted request of I. Obviously allocation has been improved because we have added some new resources to that particular process. That's why the allocation table will be updated accordingly, right? And the last one will have to update will be the need matrix. So need of I will be new need of I will be old need of I minus request of I. It is but obvious. Now if you have some given some more requested instances to that particular process, that directly means you have decreased the need by that factor, right? That's why the new need will be need of I minus request of I. So after updating these three only, after updating these three only, we will run safety algorithm on updated table, or we can say snapshot. After making these updates on the given table only, we will run safety algorithm. Now run safety algorithm, right, on these updated values, right? And after running safety algorithm, if we find, or if we find safe sequence, or we can say system is in, if after running safety algorithm we may find system in safe state, then we are allowed to resources allocate resources allocate resources to requesting process, which is pi, right? And if this is not the case, then in the else part, that requesting process pi must wait until our allocation is safe, right? So this, as we already told you as I already told you, that this resource request algorithm is simply for checking that the new request given by any particular process can be granted or not. According to it, if the request of that particular process is less than the need of that particular process, then we'll check if the request of that particular process is available in the system. If it is available, then we first we will do what we will do, we will assume that we can give we can give that those resources to that particular process. And if after giving that those resources to that particular process, we will update our table, and after updating our table, we will simply run our safety algorithm, which is here. We will run safety algorithm on that new updated table or new updated values of available, allocation and need. And if after running or executing safety algorithm on that updated table, if we are able to find any safe sequence, or we will find our system in safe state, then only we will allocate those resources to that particular process in real time. Else that particular that particular process must wait until those resources or those allocation is being found safe, right? So this is all for today. In the today we understood, or we simply made safety algorithm, steps of safety algorithm, and resource request algorithm. And I think it is at least 50% clear to you how this algorithm is working, and rest 50% you will understand when we will solve a numerical on this banker algorithm, right? So that's all for the today, guys. I think I made clear to you. Thank you, guys.